Hello everyone, in this video we are going to discuss a sorting algorithm that is known as merge sort, and it is a recursive algorithm. It is amazingly fast, faster than the algorithms for sorting we have learned till now. That is, we have learned bubble sort, insertion sort and selection sort. It is faster than all those, and we will discuss here the algorithm of merge sort. Then we will also see an example for sorting using code, and it will be a lot of fun. So let's get started. We are seeing here merge sort. So it is a recursive algorithm based on divide and conquer technique. So if we give an array, let's say its size is 10, index is from 0 to 9. If we give this array to function merge sort, so first it will divide it into two parts. Merge sort divides the array which it gets into two parts, in two equal parts. So here we will have index from 0 to 4, and here we will have 5 to 9. It will divide it into two arrays. We will divide this using mid. We will first find out mid, then divide this array 0 to 4, this one, and here it is this one, 0 to 9. Now we have two arrays divided from a single array. Now we will recursively make merge sort call on separately on these two arrays one by one. After calling merge sort, we can assume that this array has been sorted and this array has been sorted. This we will here follow the principle of recursion. We can assume that after calling merge sort, recursion will sort this array, and then we will call merge sort on this array, and we can assume that this is also has been sorted. Now we will take these two sorted arrays. Here it is 5 to 9. Here we will take these two sorted arrays and merge them into a single sorted array using a function that we will see later. We will merge two sorted arrays using the concept of merging two sorted arrays. So as it is a recursive function, we will also see here a base case. So let's discuss about the base case. If we get an array of size 0 or size 1, then we will return. We will not do anything, we will simply return, as we know that any array of size 1 is already sorted, and if it is empty then also it is sorted. So now let's take an example to understand this. Let's take an array 0, 1, 2, 3, 4. It has 5 elements: 43, 62, 4, 7, 12. So if we pass this array to merge sort function, it will simply divide it into two parts. It will divide from here. We will get this array, and we will get this array 7 and 12. Again, as we have called recursion on separately on these two arrays, again merge sort will divide this into two parts, that is 43, 62 and 4 single element, and this will also get divided into two single elements, that is 7 and 12. After that this will also get divided into two parts, that is 43, 62. Now as we have seen, after dividing the array we are merging it according to sorting rules. So as it is smaller than first one is smaller than the second one, we will simply merge them in the previous order, that is 43 then 62. Now we will merge that with 4. As 4 is smaller, 4 will come here. Now this part has become sorted, merged. Now this will get merged separately. 7, as 7 is smaller than 12, it will come before 12. After merging these two elements, we have two sorted arrays that again we will merge them into a single array according to sorting rules. As 4 is the smallest, it will come first, then 7, then 12, then 43, then 62. So in this way our whole array will get sorted. Here we will do like this. This is merging. Here it is merged 4. It is merged here. There are two ways to implement merge sort function. While dividing, we can do that. If we have an array like this, we can create two different array and copy all these values here. The we can copy the values of first part into a array, and we can copy the values of second part in another array, and then we can call merge sort on these two separately, and then we can return y merging these two sorted arrays. There is another way. We can play with indexes. If we have a single array, we are not going in this method. We are not going to create two arrays. We are just mark the indexes. It is 0, and this will be mid. This will mid plus 1. This is will be end index. This we will can say this is starting index. So we will just pass the indexes. We will not create separate arrays. So this is more efficient, as we need not to create, we need not to use more space in it. So we will use this method. Now we will see code for merge sort to merge an example array and to implement this algorithm that we have seen so far.
Now let's see the implementation of merge sort algorithm through a program. Here in main function I am defining an array int arr that is containing some elements in random order. Now finding the length of this array using formula size of array upon size of int. Now calling merge sort function, which will take three inputs, that is array, our starting index that is 0, and ending index that is length of the array minus 1. Here we are using indexes as we are not going to create two separate arrays in our merge sort function. We are going to play with indexes, so we are passing starting and ending index of the given array. After calling merge sort function, our array will get sorted, so we will print it to see our output. So we will make here cout array I and some space. Now writing merge sort function. As merge sort function is not going to return anything, it is going to make changes in the given array. So we will keep its return type void, and we will write merge sort, and it is taking three parameters. So first is int array, then int starting index, then int ending index. As we have discussed earlier about the base case of this merge sort function, it is going to be if starting index becomes greater than or equal to ending index, then we are simply going to return without performing any operation. So here are two conditions if starting index is greater than ending index. It means that our given array is empty, because if it has some element, then starting index is going to be 0, and it is going to be at least 0 if it contains one element, or greater than 0 if it is containing some elements. So this is for the case for the empty array, and if starting index becomes equal to the ending index, then our array is containing one element. In both the cases, array is already sorted, so we are not going to do anything, we are going to simply return. Then we are going to divide our given array into two parts by finding the mid of the array using formula starting index plus ending index upon 2. So after finding mid, I'm going to call merge sort on the first part of the array, that is starting from starting index and till mid. Here I am also passing mid element. After calling the first part, we have to call second part of the array, that is starting from the next element of mid, that is mid plus 1 till ending index. After having called these merge sort with the two parts of the array two times, we can assume that our given array is sorted, given two parts of arrays are sorted. First part is sorted in itself and second part is sorted in itself. Now we have to merge these two parts in the sorted order. So here I am writing a function merge array from starting index to ending index. And this merge function I am going to write. So now writing merge function. See, merge function is going to merge two sorted arrays into a single array that is sorted. So it's not going to return anything, it's going to make changes in the given array. And here we are passing our whole array, that is consist of two part. We are not passing it to separate arrays. So this merge function will also divide our array into two parts, that is already sorted by this merge sort function. Then it will use same input array to store the merged sorted sorted array. So here I am writing the function merge now it's taking array and starting index, ending index, and it is also going to find mid using same previous formula, that is starting index plus ending index by 2. Now as we have to create two separate arrays, so first we are going to find the length of two arrays. So length of first part is going to be ending index. We calculate the length of an array through indexes using the formula last index minus first index plus 1. So the last index of the first part of the array is mid, so we are writing mid minus starting index plus 1. Similarly, we are going to calculate length of the array 2, that we are giving name len2, that is its ending index is ending index, and its starting index is mid plus 1 and plus 1. So we have calculated the length of two arrays. Now we are going to allocate space for these two arrays. So I am giving name ar1 to the first array, and it's going to have length len1, creating second array named ar2 we have created two arrays dynamically here. Now as we have already created two arrays, now we are going to fill these two arrays with our main array, that is ARR. So let's make copy of starting index of the main array, and we are naming it main array index, that is starting index. So now I'm running a loop to fill the first array. So its length is len1. So it's running, this for loop is running from 0 to L1. Now AR1 will hold the value of main array index si. We have created its copy, that is main array index, and this is our first array. Similarly, we are going to fill our second array. That is AR2 at index I is going to be main arrays index, main array index plus plus. So till here we have filled our two arrays. Now we are going to merge these two array and fill the element one by one in the main array. So again initializing the one main array index with value starting index as it has been reached to ending index. So we are going to fill the main array. So I am going to create two index 1 that will keep track of the elements in array 1 and array 2. So while index 1 is less than length 1 and index 2 is less than length 2, we are going to check this condition. If in array 1 at index ind1, if it is less than array 2's element at index 2, so we are going to insert the smallest element of the two arrays to our main array, that is named ARR. So we have created its index counter, that is main AI. I will write it here, main AI plus plus is equals to AR1 index 1 plus plus. We are also updating simultaneously on the index of the array which we have taken in the main array. If it is not the case, then we will simply put a second array's element and it increase in counter in the main array. If both the arrays are of dissimilar lengths, then we have to check if they are not empty. So I am doing it here. If ind1 is less than index 1 is less than length 1, then do this part. Similarly for array 2, checking array 2, then do this part. Now as we have successfully created our merge function, so it's completed merge function, and merge sort function is also completed. Now we are going to see output of our program. Let's try to run it after clearing terminal. So as we have taken this input array, and it's showing output in sorted array. So our given array is sorted by this merge sort program. Hope you understand the